Lesson 5-4, factor and rational zeros theorems. So here's two separate ideas, but they're both pretty brief, so we'll put them together here. Factor theorem says if you divide one polynomial, say by this binomial, and you get a remainder of zero, wow, well, a remainder of zero means that these two divided perfectly. So whatever this divisor is an exact factor of the original dividend. Yeah, right. So I can tell you that. All right, so I'll do this example with you guys. Now they're suggesting synthetic division. I'll also do long division to give you guys a different perspective there. Okay, and then what is this rational zeros theorem? Now this is a fun one. This is like what would be a list of numbers that well, it's like if you're trying to find what binomial that you could factor out of an original polynomial. Like, oh, geez, it could be anything, right? Or what could the intercepts be? What could the zeros be? How would I have any idea? And what they do, just very simply, is to say, well, if you expand out the polynomial in standard form, like they have here, and you look at the coefficient on the very last term, which would be this constant, and then the very first term, so the leading coefficient on the highest degree power of x, okay? And then you take all the factors, right, of each of these numbers, okay, break them down into primes, and then divide the primes of your constant by the primes of the leading coefficient. Or I shouldn't even say primes. It could be like any factors. Right? So all the factors of what they're calling P divided by all the factors of what they're calling Q. So P over Q. Okay, you'll get a whole list of potential zeros, potential rational zeros. Okay, and let me just go and read this bit right here. Usually it is not practical to test all possible zeros of a polynomial function by substituting and evaluating the function. The rational zeros theorem can help you choose some of the possible zeros to test. Yeah, so we will do both of these examples. Right, and then when I jump into the book, we'll do factor theorem on these four right here. And then we'll do rational zeros on a couple right here. And then I got a box question, right, so geometry. Yeah, that will round out. So that is the plan. So example one, factor theorem. Let's try this. Example one. Okay. Now they're suggesting synthetic division, so maybe I'll do that one first. So we have f of x equals 2x cubed plus 15x minus 11x minus 24. So that's the original function. And what they want to know is, can you divide out x plus 8? So what is, here, spell it so it's really obvious what's going on. 2x to the 3 plus 15x minus, whoops, no, that's the square. Oops, there we go, square. Minus 11x minus 24. Can you divide all this by x plus 8? I mean, if I do that and I get a remainder, then it would not divide evenly, like x plus 8 would not be a factor. But if you get a remainder of 0, oh, then they do divide. Right? In fact, then you could carry on the puzzle from there, right? So you can factor that out. Okay? So let's try this with the synthetic division first, since that's what they're suggesting. So let's take these coefficients, 2, 15, negative 11, negative 24. 2, 15, negative 11, negative 24. Okay? And if we're factoring out x plus 8, remember, what goes in this box is like, well, like an A if you're factoring out x minus A, so x minus negative 8. So I have to put in negative 8. And that's exactly what they did too. Right? So careful about that. Okay? So let's go through, drop down the 2 times negative 8 is negative 16. Add these going down, it's negative 1. Times negative 8 is positive 8. Add going down, it should be negative 3, right? Then times negative 8 is positive 24. Add going down, it is 0. Yeah, so you have a remainder of 0, which means that these two divided evenly, and x plus 8 is, in fact, a factor of this original crazy looking polynomial. Okay? Actually, I can interpret what the quotient is going to be too. Okay? So this divided by this, I'll say is equal to, yeah, we have an arrow. I'm just going to direct right down here. We say equals. Okay? So what is all this right here? It's equal to, well, here's your answer. So x plus 8, I just factored out. And then what you have left is 2x squared minus x minus 3, like that. So that, right? What I boxed down here, actually, I'm being Okay, that's that. Okay, actually, if I get rid of this x plus 8, that's what they divide out to. That's what I should say. Okay. Or I could alternatively say the original f of x. Okay, that's better interpretation. Okay. The original f of x, this original polynomial that they gave us, does factor like this. Okay. Now, could you go another step? Could you factor this? Sometimes you can, sometimes you can't. Okay. But here, I'm going to move on to the long division version of this. So do I get the same thing from long division? Let's try this out. So I get 2x cubed plus 15x squared minus 11x minus 24. Right, so just copy that down. I'm dividing out x plus 8. Right, so how many times does x go into 2x cubed? Well, that'll be 2x squared times 2x squared times x is 2x cubed. And then don't forget 2x squared times 8, which is 16x squared. Then subtract this off. Now, where's pink ink? Gonna reverse all the signs here just so I don't trip over the negatives. So plus, minus, minus. So of course this goes away as it should. And then this is negative x squared. Okay? Then drop down to negative 11x and then just rinse and repeat all the way to the end. And I should get a remainder of 0 because, well, I saw this factored out perfectly. So let's see if that's still true. How many times does x go into negative x squared? I think that would be negative x times. So negative x times x is negative x squared, and then negative x times 8 is negative 8x. Okay? Then subtract this off. So plus, plus, plus. That gives me negative 3x. Then finally drop down negative 24. So I think I need a negative 3 right here. So negative 3 times x is negative 3x. Negative 3 times 8 is negative 24. And oh, look at that. It worked out perfectly. It's plus, plus, plus. This whole thing zeroes out. There's no remainder. So there's the quotient. Right, so what that means is that the original statement, or the original polynomial f of x, which I have right here, right, as this dividend right here, is the same thing as this x plus 8, which I factored out, times this quotient, which is 2x squared minus x minus 3. Okay? So f of x is right here, and f of x is also right here. They're the same thing. They're identical. We've got remainders here. Oh, also, I did do this with synthetic division. So did I get the same thing with synthetic division? X plus 8, 2x squared minus x minus 3. X plus 8, 2x squared minus x plus 8. Yeah, it's the same thing. It's the same thing. Here's synthetic division. There's long division. Same thing, same thing. That's good. Right, so if you divide, say, a polynomial by a binomial, and you get a remainder of 0, then you know that you found a perfect factor. Yeah, that's about it. All right. Right. And the other half of this lesson is, well, what are some possible zeros? So to give you an example here, example 2. Okay. We got f of x is 4x to the fifth plus x to the fourth minus 2x to the 3 minus 5x squared plus 8x plus 16. Okay. Now for possible zeros, I'll say possible rational zeros. Okay. They have this P over Q method. And for P and Q, you just need the factors of this last number 16 and the factors of this very first coefficient 4. Okay. None of this stuff in the middle really matters at all. You can just ignore all this. Right? All you care about is P over Q, which is factors of 16 over factors of 4. Okay. Yeah, okay, and they listed out here what those factors are. Right? Like you could make a factor tree, something like that. So like what numbers could multiply to 16? Well, P could be, or it could be plus or minus, so careful about that. Because you could have like -2 times -8, so careful. That could be positive 16. So we got plus or minus 1, shows up a lot. Anytime you have an even number, we get plus or minus 2. 60, well, 3 doesn't go to 16, but 4 does. So plus or minus 4. See, 5, no, 6, no, 7, no, 8. And also the number itself. So don't forget plus or minus 16. Okay, so that's a lot of factors there. Okay, and then Q, okay, factors of 4, that'll be plus or minus 1, plus or minus 2, plus or minus 4. Okay, so I have 2, 4, 6. I'm counting by twos because the plus or minus counts as two different numbers. You got 2, 4, 6, 8, 10 different numbers that could fit in the numerator, and 2, 4, 6 numbers that could fit in the denominator. So that's a lot of uh, values I have to check. So P over Q, and I'll kind of cheat off the book right here because it tells me what they're going to be. But let's just go through. Like, I mean, if you have 1 divided by 1, that would be 1. And if one of these was negative, it'd be negative. Okay. So plus or minus 1 is going to work. Okay. Same thing with 2 over 1, 4 over 1, 8 over 1, 16 over 1. I mean, you can divide anything by 1. So those will all work. Plus minus 2, plus minus 4, plus minus 8, plus minus 16. Okay. What else we got? Well, you could also take any of these numbers and divide by this plus or minus 2. So 1 divided by 2 is 1/2, right? You could also have the negative version. So plus minus a half. 2 over 2, well, that's taken care of already by this. Right? I think I saw in your Alex assignment, they mentioned some version of, I forget exactly how it's phrased, like make sure you don't repeat potential zeros, because otherwise you might say, oh, hey, 2 over 2, that's 1, but we already took care of that. Don't have to write it again. How about 4 over 2, 2 took care of it here. 8 over 2 took care of it here. 16 over 2 took care of it here. Okay, so we're kind of done dividing by 2. Let's move on to this 4. So it could be 1 over 4. And then, again, the plus or minus version of that, 1 over 4. Now, 2 over 4 is a half. Well, I took care of that here. Yeah, everything else I think is already taken care of. 4 over 4 is 1. 8 over 4 is 2. 16 over 4 is 4. Yeah, I think that's it. That should be an exhaustive list right here. Okay? Now, keep in mind that uh, this is like we're taking this original polynomial, we're trying to find factors. So maybe I want to factor out like x plus 1. Now, x plus 1 might factor out because of this right here, and x minus 1 might factor out. Okay? Or maybe it doesn't. Okay? So not all of these are going to work. It's just this is a really good candidate list to start hunting around for uh, binomial factors that we could pull out of this original polynomial. Okay? So maybe I could do like x minus 2 and either do long division or synthetic division and test that out. Right? And then how about x minus a half, x minus a quarter, and so on. So I could try all these. There's 2, 4, 6, 8, 10, 12, 14. There's 14 different potential like good candidates here. Okay? And they probably don't all work, but maybe some of them do. And then I could use either long division or synthetic division to narrow down the list until I find something that works. So that's pretty much the theory. Yeah, that's sure. All right, so let's try some of these. What we got here? Given a polynomial and one of its factors, find the remaining factors. So given you here, or 5. So we got a polynomial 2x cubed. Maybe I'll say f of x equals, how about that? Okay. 2x cubed plus 17x squared plus 23x minus 42. And they're telling us that x minus 1 is one of the factors. Okay? Now you could do synthetic division or long division. I'm going to use long division for this reason. I remember that when there's, or no, wait, I'm being silly. Actually, it doesn't matter. Let's just use synthetic. Maybe one of these I'll say long division for, but just to change it up a little bit. Let's do synthetic. So let's do synthetic division, right? Because if you can't get it to work, it's usually faster. I think you guys have seen that. So copy down this coefficient, make sure I got all the powers of x. 3, 2, 1, 0. So we're going that right. Copy down this coefficients. I got a 2, I got a 17, I got a 23, I got a negative 42, right? And they're telling us that one of the factors is x minus 1. So I'm going to put positive 1 in this box right here. It's like x minus a. In this case, a is 1, so you got x minus 1. All right, so let's go through it. Now, I should get a remainder of 0 here. If I don't get a remainder of 0, then either I messed up or they lied to us. Okay? So I should get 0. Now, once I have that, see, I'll get this quotient, and then I can further factor that. So, which is exactly what they want us to do. They want us to find all the factors. So 2 times this 1 is 2. Add going down, it's 19. This 1 is 19. 9, 10, 11, 12. Carry the 1. 4, 42 times 1. Yeah, look at that. 42 goes to 0. Right. Ooh, okay, so that's good. Because if that wasn't 0, that would have been an issue. Right. But we're good. So f of x, the reason I call it f of x is so I can also write it here, is the same thing as x minus 1, which they gave. They told us that it was going to work. They told us it was going to work. I tried it out with synthetic division. It totally worked. And what I'm left with is this 2, x squared. I got a plus 19x and plus a 42. Right? Okay, so now next question is, can I find a way to factor this? Right. Um, Here, let me see what I can come up with. Okay, so I paused the video just for a minute so I could think of some possibilities. And I think how it's going to work out, this 42, I think it's going to break down 6 and 7. Now, this 2x squared, I need a 2x and an x. And what I'm thinking is if I can get the 2 and the 6 to multiply, that could be 12. And if I add the 7, that would bring me back to 19, which would be good. So I'm going to put the 2x right here and the x right here, plus plus. Let me check my work. So 2x squared, bing, got 7x plus 12x is 19x, bing, 6.742, bing. Yeah, that's it. So this is as much as you can factor f of x. So this original statement right here fully factors into this, right? But look, actually, guys, that's not even a lot of paper. Like I got 1, 2, 3, 4, 5, 6 lines. It just fits on this thing. Yeah, just a little over half a page right there. So that actually worked out pretty fast. That's pretty good. Next one, number 7. I'll say, how about g of x? Let's call it. I got an x to the 4 plus 2x to the 3 plus 2x squared minus 2x minus 3. And they're telling us that x minus 1 is a factor. Oh, hey, that's the same factor as it was before. Okay, that's nice. And so here, I'll try synthetic division again. I'll just do synthetic division for most of these. And maybe this last one, number 11, I'll double check with long division just to change it up. So I'll write down the fact, yeah, the coefficients. I got 1, 2, 2, -2, and -3. Okay. Now we're factoring out x minus 1. So with synthetic division, I'll put +1 here. Right? So got 1 times 1 is 1. Add those up, it's 3. Times 1 is 3. Add those, it's 5. Times 1 is 5. That's 3. Times 1 is 3 and 0. Aha. Okay. So that number again had to be 0. That means it's a remainder of 0, which means that this factored nicely. Right, so g of x, I'm calling it here, is equal to, well, I know x minus 1 pulls out because they told us it would, and I tested it, and it sure did. We got a remainder 0. That's okay. And what I'm left with is I got an x to the power of 3 plus 3x squared plus 5x plus 3. Looks like that. Okay, so now what? All right, so again, pause the video just for a minute. What I was going to do, here, I'll tell you my thought process, which is probably the most important thing you get out of something like this, okay? Is I was thinking, hey, let me try this rational zeros theorem and try factors of p over q, so like 3 over 1, -3 over 1, -1 over 1, right? And plug it in here. I couldn't get anything else to factor out of this, though, so I'm just going to call that a wrap on that one and move on. I don't know if I can factor that anymore. It's number 9. I got, here, I'll call it h of x. All right, we got x to the 3 plus 2x squared minus x minus 2. It's telling us x plus 1 is going to factor out of this. So, okay, 3, 2, 1, 0. Okay, got all my powers of x. We'll write those coefficients. So 1, 2, -1, and -2. Okay? And then in my box, see, they're telling us x plus 1 is going to factor out. So I'm going to put -1. Just remember, it's always x minus a. Goes in that synthetic division box. All right, and here we go. Drop down to 1 times this -1, this -1. Add these going down. That's +1. Okay. Okay, then multiply this one by -1. That gives me -1. Add going down is -2. Times -1 is +2. Add going down 0. Okay, good. Then we've got a remainder of 0. So this did factor out. So I could say h of x, therefore, is x plus 1, of course, because they told us it would factor out and tested it, and it did. And what I'm left with is this x squared plus x minus 2. Just like that. Okay. Now, will that factor? How about this? How about this? H of x equals, okay, so I'll keep this x plus 1 here. Okay. What are two numbers that multiply to -2 and add to 1? I think it'd be +2 and -1, wouldn't it? Positive, +2 and -1. So x plus 2, x minus 1, something like that. So you got x squared. Yeah. It's 2x minus. Yeah, that's it. Okay. So there you go. There's the full factorization right there. Full factorization. So this original h of x fully factors like this. That's it. That's all the factors. We're good. We're good. And number 11. Right, so, like I promised you guys, I'll do a little extra with this one. So I'll do synthetic division, but also I'll do long division and show you guys it works both ways. Let's call this j of x. Why not? I got x to the 3 plus 3x squared minus 4x minus 12. Now they're telling us x plus 3 is going to factor out. So I'll write down these coefficients of 1, 3, -4, -12. Okay. And we're factoring out x plus 3, so I'll put a -3 in the synthetic division box. Okay, let's do synthetic division first. I'll spell it out. Synthetic division to distinguish it from what I'll do next. Okay, so drop down the 1 times this -3 is -3. Add that, that's 0. So 0 times anything is 0. Add 1 down is -4 times -3 is +12. 0. Yeah, 0 remainder. So j of x therefore equals. Okay, so I just pull out an x plus 3. That's what's represented by this. Okay. What I'm left with is I got an x squared right here. I got no x's at all, and I have a -4. Oh, well, I can factor this. Guys, this is a difference in two squares. Isn't this x minus 2x plus 2? So j of x is, I got x plus 3, I got x minus 2, and x plus 2. That's the full factorization. Like that. Okay. Let's try this exact same question, number 11. So I'll still stay on number 11. But let's try this with long division. So change it up. Remind you guys how long divisions work. And I mean, it should be the same answer, of course, but just a different way to get there. So I'll write this whole expression, this whole original polynomial, which is now going to be the dividend. X to the 3 plus 3x squared minus 4x minus 12. Okay. And I'm dividing that by, now they did suggest the first term to factor out, which is x plus 3. Okay. Remember the synthetic division version, it's like x minus a, you put the a in this box. But with the long division, you write out the whole binomial. So this kind of takes the place of this. Right? Same thing. There you go. All right, now long division. How many times does x go into x cubed? Well, that'll be x squared times. So x squared times x is x cubed, and then x squared times 3 is 3x squared. Subtract that. Oh, look at this. I'm subtracting this from itself. So this whole thing zeroes out. So drop down to -4x. All right. Here, I'll just drop down the rest of it. Right. So kind of skip through a step because this interestingly enough zeroed out. I wonder if that has anything to do with the fact that this showed up as 0. Right, probably so, I think. All right. How about x goes into -4x? I think -4 times. -4 times x is -4x. -4 times 3 is -12. And oh, look at that. That also zeroes out, which means that there is no remainder on top of this. So yeah, this factored perfectly, which it should have. And we're left with this. So if I say, what is j of x? Now, j of x, of course, is this whole polynomial in standard form. But I just found out what it looks like. Well, as I'm starting to factor it, it could be x plus 3. And then here's what I'm left with, x squared minus 4. It's the same thing. This is the same thing as this. Same thing. Right? And then just like before, I can say, oh, well, I could factor that last binomial. So x plus 3, x minus 2, x plus 2. There you go. That's it. Same thing we got before. There's the synthetic division version. There's the long division version. It's the same thing. All right. All right. Ooh, rational zeros. Okay, so this was the other half of this lesson, was what are the potential rational zeros? So number 23 right here. 23. Okay. So we got f of x is 3x to the 4 minus x cubed plus 4. Okay. Now, all you really need to focus on are these two numbers. Okay. Okay, so P could be factors of 4, which could be plus or minus 1, plus or minus 2, plus or minus 4. And Q, it's a Q right there, could be factors of this 3, which should be plus or minus 1, plus or minus 3, and that's it. Okay? And then, so what's my P over Q? So I need to pair every one of these 6 P's, because there's 2 here, 2 here, and 2 here. The plus or minus counts for 2 numbers. Okay? Divided by each of these 4 Q's, because there's 2 here and 2 here, that's 4 Q's. Okay? And then some of them might repeat, like this 2 over 1, or wait, never mind. You know what? I'm gonna get a lot of these. Well, let's just go through it, see what we get. Okay. And I can just do plus or minus just to take care of 2 at a time. Okay. Like 1 over 1 would be 1. 2 over 1 would be 2. 4 over 1 would be 4. And each of these has the plus or minus version. Okay. Now that's not all, because I also got this 3 right here. So that's plus or minus 1 over 3, plus or minus 2 over 3, and plus or minus 4 over 3. That's number 23. Yeah. Okay. So I'm looking at the teacher's guide off screen, and they got the exact same 6 values that well, actually 12, right? Because 6, but then plus or minus, you get 12 values there, right? And so remember what the purpose of this is. Purpose of this is these are possible rational zeros. Okay? So if I wanted to figure out how could I factor this, it's like, well, I mean, what number do I start dividing by? Okay? I could I now have a much narrowed list. I am down to these 12 possibilities. Okay? So I might pick like x minus 1. Can I factor x minus 1 out of this? Or if I was doing synthetic division, I could just put a 1, right, and see if that runs. Right? And then, okay, if that doesn't work, I go to the next one, maybe negative 1. And if that doesn't work, go on to the next one, right? Until maybe you've exhausted the list by getting to like 4/3 and negative 4/3. Okay? And possibly 1 or 2 or more of these might give you a remainder of 0, in which case they were perfect factors. That's how you know that. Right? All right, let's do 25. 25. We got f of x equals x cubed minus 6x squared minus 8x plus 24. I should show you guys also how this is consistent with what we did before, but here, let's do this. So my values of p are plus or minus, well, factors of 24. That's 1, 2, 3 is a factor of 24, because 3 times 8. 4 is 4 times 6. Okay. Now, 5 doesn't work, but 6 does, because 6 times 4. Okay. 8 works, because 8 times 3. And 12, and because 12 times 2. And don't forget, of course, the number itself, which is 24. Woo! So that's 16 different values. There's 8 numbers and then the plus or minus version of each one. 16 values. Now, values of Q, well, I think that's a lot easier. There's just a couple, there's plus 1, minus 1. Okay? Which actually means, hey, actually, if I'm just divided by plus or minus 1, then the answer is this list right here. I mean, that is the answer. So, right. So those are all the potential zeros. Okay? Now, right. Ideally, I'd like to kind of hunt around and play with this, but this might take a few minutes to figure one that actually works. Okay? But you know what I know will work is if I just very simply flip back a page, they give you a whole page of examples right here because they gave you some crazy polynomials and they told you like some value that would factor out. So here, maybe I'll hold this up to the camera. Look at this 4 that we just did a few minutes ago. So like number 5, they told you that x minus, well, okay, I guess 1, right? Because factors of 42 divided by factors of 2. Well, one of those would be 1, like 1 over 1. And so you get that. Same thing there, same thing there. Okay. Now, how about number 11 might be more interesting because, let's see, factors of 12 over factors of 1. And one of those would be 3, wouldn't it? Like 3, negative 3, so plus or minus 3. Yeah, so that could work. How about number 13? Factors of 90 over factors of 1. Yeah, I think 5, plus or minus 5 could be a factor of 90. So that could work. How about, there's anything more exciting here? Here, how about 8, number 8, okay? So the P, you've got factors of 7, and the Q is factors of 3. So yeah, one value you could put, I've got plus or minus 7 going on right here. Yeah, so that works. Yeah, so you can see how rational zeros is consistent with all the examples we've done so far. Okay, but I'll do one more puzzle with you guys. Let's do this number 26 geometry right here. 26 geometry. volume of the box with the square base, it has this volume. So I'll go ahead and write that down. Volume as a function of x equals 2x to the 3 plus 15x squared plus 36x plus 27. Okay. Now, I don't know what this box looks like exactly, but it is interesting they mentioned a square base. So, try to kind of get a picture. Right? So whatever this width is, this depth is the same value. Now, I don't know if it's x or if it's something else crazy, but I guess it's like a repeated value, right? What it happens to be. Right? And okay, so this box is so tall. Okay, something like this. Okay, so that can be about right. I didn't try to make it a cube, but it's not necessarily a cube, right? But it does have a square base though. It says the height of the box right here. Give me that. Is 2x plus 3 units. What are the measures of the sides, also in terms of x? Okay, well, all I have to do is take this original polynomial and divide by this binomial height, and that would give me the answer. Okay. Now, okay, here's where the fact that there's a factor on those two, there is an extra step you have to do if you wanted to apply the synthetic division method. So just to avoid the extra tricky step, right? I'm just going to use long division. Right? I think I'm less likely to run into errors that way. So let's do long division. So long division, I'm going to use long division. So let's go 2x to the 3, 15x squared 36x 27. We're dividing this all by 2x plus 3. Okay, here we go. So how many times is 2x going to 2x to the 3? Well, that would be x squared times. This x squared times that is 2x to the 3. That's a match. That's good. Now x squared times 3 is 3x squared. Subtract this off. So this goes plus minus minus. This zeroes out, which it should. And then this leaves me with 12x squared. Okay. Now drop down the 36x. How many times does 2x go into 12x squared? Well, it'll be 6x times. So 6x. 6x times 2x is 12x squared. 6x times 3 is 18x. Subtract this off. So plus minus minus. It's going to give me 18x right here, and then drop down to 27. How many times does 2x go into 18x? That would be 9 times. 9 times 2x is 18x. 9 times 3 is 27. Woo! Okay. All right, so I was hoping that would zero out. Like it gives me zero remainder. It does. It does. Right, that's good because that means that this height does perfectly factor out of this original volume function. Right, so pick up here. Okay. So the volume as a function of x. Okay. Now they wrote out this whole polynomial in standard form, but now I can write it in well, a more factored form. I know that height is 2x plus 3. And if I factor that out of the original statement, which I just did, I'm left with this quotient right here. X squared plus 6x plus 9. Okay. Now, I do remember the hint they gave us back at the beginning, which is they said this box has a square base. So I suspect that this last polynomial I'm left with is a perfect square or something. So can I make that a perfect square? So I still got this height of 2x plus 3. So something squared, right? So, hey, how about x plus 3? X plus 3, right? Because if I square that, x squared, bing, 3x and 2x is 6x, bing, 3 squared is 9, bing. Yeah, that's it. That's it. Yeah. So go back to the original box. If I want to draw on the sides, this side right here would be x plus 3, as would be this side, hence the square base, x plus 3. There you go. That's the answer. Oh, yeah. Oh, yeah. That's pretty good. It all worked out.